Good morning, children. Today we will continue with what we did last time. Chapter number 4. Chapter number 4, light, and we'll be discussing part 2. Today we will talk about mirrors. So, when a mirror is made, it has to have certain characteristics, and these characteristics are: it should have maximum reflection, it should not absorb any light, and the last one is it should not transmit any light. So these are the three characteristics of a plane mirror. It should reflect, it should have maximum reflection, that means the light which is falling on the mirror should not be absorbed as far as possible. It should not absorb any light, and it should not transmit, means the light should not pass through the mirror. Most of the light that hits the mirror should bounce off. Now, let us talk about how a mirror is constructed. Now, a mirror is made of a plain sheet of glass. As you know, a glass is normally used in windows and light easily passes through. So what is done is, on the surface of, on one of the surfaces, it is silver. So let's say if the top surface is silver, then this hash line that I am using here is to represent the silvering surface. So this portion becomes the back of the mirror, and this side of the glass becomes the reflecting side. So once again, a mirror is made of a plain sheet of glass, clear glass, in which one side is silver. The silver side becomes the back of the mirror, and the opposite side becomes the reflecting surface, and this is the side that reflects the light. Now, normally you see a mirror which has a plane surface. So those are called plane mirrors, but there are also other types of mirrors as well. The first one which you normally see is a plane mirror. It has a straight surface, and one side is silver. So this is the back of the mirror, and the opposite surface becomes the reflecting surface. Now, there is also another kind of mirror which is made spherical. It's like a sphere. If you cut the sphere, it's like a ball shape. If you cut the sphere into two parts, so you have two curved surfaces like this, and either side can be silvered. Now, if the outer side is silvered, like this, so this becomes the back of the mirror, and this becomes the reflecting surface. So this mirror which is curved and reflecting surface is on the inside, this kind of mirror is called a concave mirror. You can just remember this kind of mirror is because you can think of the word cave. A cave is something that is deep and goes inside. So this mirror is something that goes deep inside. So you can remember this as a concave mirror. The other part of the mirror, if you silver the inside of the mirror, so this becomes the back of mirror, and this becomes the reflecting surface. So as you can see, the outside surface becomes reflecting surface. So this kind of mirror is called convex mirror. So once again, there are three types of mirrors. One is a plane mirror. A plane mirror has got a straight surface in which one side is silvered, which becomes the back, and other side becomes reflective. If you take a sphere, a glass sphere, and you cut it into two parts, and in the two parts, if you silver the outside, the inside becomes reflecting. This type of mirror is called a concave mirror. If you silver on the inside, and this becomes the back of the mirror, and the outside becomes reflecting, this kind of mirror is called a convex mirror. When you look at a mirror, you can see an image of yourself. So exactly how that happens, we will discuss here. Let us say this is a plane mirror and this is the back surface. So let's call it this mirror as LM. This is the reflecting side, and let's say we have a point object, I will call that O. Now, on the same side of the mirror, let's say here is an observer, and I am drawing the eye of the observer here. Okay. What is going to happen is, this object radiates light in all directions, and let us consider only two rays. The first ray of light, it strikes the mirror, and it gets reflected. And if you remember, if you draw a perpendicular line at the point of incidence, this is called the normal, and the angle between the incident ray and the normal becomes the angle of reflection, angle R, and I'll call this angle R1. So this ray of light gets reflected in such a way that, this is called angle of incidence, and this is called angle of reflection, I'll call R1. It reflects such a way that angle I is equal to angle R, in this case R1. Let us take one more ray which strikes the mirror, and I will draw a normal here. Let's say this angle of incidence is called angle I2, and this ray of light also gets reflected, and I'll call it angle R2 in such a way that angle I2 is equal to angle R2. That means angle of incidence and angle of reflection is equal. Now these two rays, if you produce it backwards behind the mirror, see, mirror is actually an opaque object, so the light really doesn't go behind the mirror. So we will use a broken line to represent light, the ray of light going backwards. So if you join it, you will find that it meets at a point. So this becomes the image. This is the object, from the object, the rays of light gets reflected by the mirror and it enters the eye. This ray of light, if you produce it backwards with a broken line, it meets at a point behind the mirror and that becomes your image. So this is how the reflection of light works in a plane mirror. Let us discuss the next topic, which is called lateral inversion. Supposing this is the mirror and you are standing in front of the mirror. Your reflection will take place. You will see a reflection on the back of the mirror. Now, if you notice that if you're standing and looking in the mirror, you will see yourself, and if you raise your right hand, you will find that the mirror will raise its left hand. This is because of a phenomenon called lateral inversion. Now, supposing if you have alphabet B and if you look at this alphabet on the reflection of the alphabet on the mirror, you will find that B actually looks like this. It's laterally inverted. So this change of side, when the image is seen in a mirror, this phenomenon is called lateral inversion. You must have noticed in an ambulance, the ambulance is written in the reverse order. So this is A M B U L A N C E. In the ambulance, the alphabets are in reverse order because when the driver in front of the ambulance sees that alphabets in their rearview mirror, that person will actually see the alphabets spelled out properly in a proper way. So this is one of the reasons why you see that the alphabet in the ambulance in the front is in the reverse order, so that when it is reflected by the mirror, you will see it in a straight and proper way. Now let us discuss the characteristics of the image. Characteristics of the image formed by a plane mirror. So let me draw the diagram again. So if this is the plane mirror, this is the back, this is the reflecting surface, and let's say this is the object. Okay, so you are standing there and this is your image. This is the object and this is the image reflected. Now what are the properties? First of all, you notice that the size of the object and the size of the image is the same. Okay, so that's the first property, that is the object and the image is of same size. Secondly, the image is erect. That means if you are standing straight, that means your feet are here, head is here, the feet is also on the bottom and head is also on the top. So head is directly related to the head and feet, wherever the feet is exactly there. So that means you are standing erect. It is not upside down. It is not that your head is here and your feet is upside down. It is not like this. So the image formed by a plane mirror is erect. The third one is the image distance and the object distance is equal. That means if you are standing a distance of 1 meter from the mirror, the image will also be standing a distance of 1 meter from the mirror. Supposing if you move backwards, the image will also move backwards. If you move forward, the image will also move forward to make and will ensure that the distance between the object of the mirror and the image is equal. So this is the third property, that is image distance equals object distance, and the last property is the image is laterally inverted. This I already discussed a moment ago in lateral inversion. That means if you are standing as an object and you raise your right hand, the image will raise its left hand. So this is what is meant by that the image is laterally inverted. Now the last topic or the last section for today is the uses of plane mirror. Number 8, it is used as a looking glass. This is the most common use of a plane mirror. If you remember, every time you get up in the morning, you go to the bathroom, there's a mirror in front of you. So that's where you look at yourself, wash your face, you brush your teeth, and you comb your hair. You need to look at the image and you are able to do the action because you can see yourself in the mirror. So the most common use for a mirror is as a looking glass. Number B, it is used as a solar cooker. In this case, what is done is you have a box which is painted black inside, and a plain glass is placed on top of that, and then a mirror is used on the top in such a way that the rays from the sun gets reflected into the box. So what happens here is that the rays of the sun, the heat from the rays of the sun gets reflected by the mirror and goes into the box, and because the box is painted black, the black paint absorbs the heat, and this glass that is placed on top basically prevents the heat from coming out, so the heat gets stored inside and it raises the temperature of the box inside, and that raised temperature can be used to cook items. So if you put certain food items inside it, that will actually cook, and you can also use it for warming. Number C, it is used for mirror signaling. Now, as you know, a mirror has reflective properties. So, supposing if you want to attract the attention of a person who is very far away, and the sun, and during the day, you can use the mirror and you can reflect the rays of light into the eyes of the person and attract the attention of that person. So you also must have sometimes played fun on your friends by using the mirror and reflecting the light of the sun into the eyes. So it's the same way in which the mirror can be used for signaling, basically to attract the attention of a person who is very far away by reflecting the light using a small mirror. So these are used by scouts and guides and some of the organizations to attract attention of a person who is very far away using mirror signaling. Next is, it is used for showcase display. If you notice in the jewelry shop, the jewelers, they display all the ornaments, and if you notice that in the showcase they use mirrors in the front and the back, so that you can see the jewelry from every angle, and also it reflects light and it makes the showcase brighter. So this is the use of using a mirror in showcase display. Number E, it is used in periscope. In a periscope, supposing if you want to see over a high wall and you are not very tall and you are not able to see. See, your line of sight is here and this is getting blocked. And supposing if you want to see an object on the other side, you will not be able to see that. So what is done is, you place, in the line of sight, you place a mirror and over the wall, you place another mirror like this. So what happens is that this, your line of sight will be directed by the mirror to the first mirror and then reflected to the second mirror and it will be going over the wall. So rays of light coming from the other side of the wall will be reflected by the first mirror into the second mirror and enter into your eye. So in this way, if you use two mirrors in this fashion, you will be actually be able to see over the wall, and this is the principle of how a periscope works. Periscopes are normally used in submarines where staying underwater you can look above the surface of the water. So this is an advantage to a submarine. Without having to come to the surface, they can see above the surface of water by using a periscope like this. So whenever they want to see above the surface, they raise the periscope, look, and they pull the periscope down. The next use is a kaleidoscope. Kaleidoscope. A kaleidoscope is basically a toy in which you take three strips of mirrors like this of equal size and you place it in the form of a triangle in this way and cover the tape with the reflecting side inside. And on one side over here, okay, you will put a transparent paper or plastic, and then from the other side you will insert broken bangles and bright colored objects or pearls inside, and when you look through the side you will see the reflected bangles or broken pieces or whatever it is that you put inside, and it makes a beautiful pattern. So this is basically a toy which is, there are three strips of mirrors in a triangle covered by a transparent plastic and bits of pieces of bangles or pearls are put inside, and you can see beautiful designs. So this is a kaleidoscope. And in optical instruments, if you have noticed, whenever you go to a dentist, the dentist has to look inside your mouth. So the dentist uses a small tool which has a long handle like this, and it has got a round surface like this, and this round surface actually hosts a mirror. So the doctor is able to put this put this mirror inside your mouth and is able to see your teeth from all different angles, so that to find out whether there is any cavities or not. So this is the way a mirror can be used in optical instruments. So this is the second part is over. So we'll meet you in the next class. Thank you.